Hello, my name is Phi. In this talk, I present our vision towards a generative approach for table semantic interpretation. What motivates us? Nowadays, table is one of the most popular data structure used to present and store information in the web. However, despite of its massive amount and human reliability, table may be insufficiently interpreted. Our goal is to understand the semantics of the table by linking the elements in the table to entities or relations in a knowledge graph. For example, given this table and this graph, we have more information about our happy lives, which is a French film and it was filmed in Penford, or Penford is a French city. To provide the semantics of the table, we perform 5 annotation tasks. Topic annotation aims to find a subject or a concept that the table refers to. This one refers to sport club. Cell entity annotation link a mention to an entity. Arsenal refers to Arsenal Football Club. Column type annotation predict a type for a column. Association Football Club represent the column 0. Column properties annotation predict a relation between a pair of columns. Column 0 relates to column 2 via a relation home value. Route to instance label an entire route in the table with an entity. This route refers to a category of Aston Villa Football Club. Our team has developed on WSN a system performing those annotation tasks. The pipeline includes 3 main steps. Table preprocessing. We clean the table and extract some metadata, like orientation, whether the table is horizontal or vertical, header, the key column in the table, and extract some basis data type of every columns, like number or objects. Second step is about candidate generation. We use a mention-based entity lookup to find a number of entity candidates for the elements in the table. And our lookup is based on an alias table of the knowledge graph, and is conducted using Elasticsearch. Third step is the re-ranking. We select the most relevant candidates for each table element. The disambiguation or the re-ranking is done iteratively, leveraging the mutual interaction between cells and columns. The score is calculated by the similarity between the context in the table and the context in the graph, as well as the relevance between the table header and the description of the entity. To give a number on the performance of WSN, we report the score in the challenge of table annotation last year. During the development of WSN, we faced some challenges and learned several things. First, table is highly heterogeneous with diverse and complex structure. Second, large portion of annotation system, including WSN, is heuristic-based. The performance depends greatly on the matching level between table context and graph context. Finally, target detection and candidate entity generation for table elements is challenging. We use heuristics to determine which cells and columns to annotate. Although our entity lookup is able to handle various surface forms of mention, like abbreviation, it does not consider the table context. For eclipse of semantics, we can make the later disambiguation more challenging. Given those observations, we are working towards a novel end-to-end annotation system leveraging the powerful large language model, able to handle simultaneously various annotation tasks and supporting various table types and layouts. In a macro perspective, we frame the annotation task as task completion task, and the model generates the annotation in an auto-reflexive way. The output annotation can be either in the form of text generated by a large language model such as GPT or Llama, or can be in the form of code generated by a code language model like StarCoder or Codify. In order to achieve a performant generative annotation system, in our opinion, there are several things to be evaluated. First, the solving framework should be unified and versatile, with the ability to learn, multitask, and to understand the structural information of the table. Second, the detection of the targets and the annotation should be performed at once to avoid error propagation from detection to annotation. And the generation of the annotation needs to ensure the consistency in structure and semantics. As we need a knowledge graph to crawl the semantics of the table, it is necessary to have an efficient knowledge graph indexing and exploitation. For conclusion, we presented the YSN, a system for annotating tables semantically. Please check out our API and papers for more information about the topic. For visuals, we are building an overall annotation system using large language model, as we mentioned in the previous slide. Importantly, we will analyze the behavior of large language model on understanding the structural and semantic information of tabular data. Thank you for listening.